Welcome back to Factoring Day 2. We are going to, again, factor some trinomials, this time when a is not 1. So we are going to start with our x method doing the same steps we did before. We will multiply a times c, put that in the top of our x. Whatever b is goes in the bottom. That is how we find our two values, m and n. They need to multiply to the top number and add to the bottom number. This is where the extra step comes in. I am then going to have to divide both m and n by whatever a is. If those result in whole numbers, that's great. If not, I'm going to have to clear the fraction. So that is best explained in practice. So let's jump ahead to these examples. Starting on example A here, my A value is 5, my C value is 20. That means the top of my X will be 100. Our B value is 29. So I need two numbers that multiply to 100 and add to 29. Well, that is 25 and 4. So because a is bigger than 1, I now need to divide both of those values by 5. 25 divided by 5 is 5, but 4/5 cannot be simplified into a whole number. So what I've got to start with is x plus 5 times x plus 4/5. This is where I need to clear the fraction. The first parentheses can stay the same because I don't have a fraction to clear, but for the second one, in order to clear the fraction, I'm going to have to multiply both the x and the fraction by whatever my denominator is. So that will give me 5x plus, when I multiply by the denominator, it cancels, and I'm just left with my numerator, 4. And I can always FOIL this back out to make sure I did it correctly. Moving on to B, a times c, 2 times 6 gives me 12. My b value is 13. Two numbers that multiply to 12 and add to 13 are 12 and 1. I need to divide both of those by 2. That's my a value. 12 divided by 2 is 6. 1/2 cannot reduce to a whole number, so far I've got x plus 6 and x plus 1/2. So my first parentheses will stay the same. For my second one, to get rid of that fraction, again, I multiply by the denominator, which is 2. So what that will give me is 2x plus 1. Again, when you multiply by the denominator, it cancels, and you are just left with the numerator. Moving on to C, 3 times -2 gives me -6. My b value is 1. Numbers that multiply to -6 and add to 1 are 3 and -2. I'm going to divide both of those by my a value. 3 divided by 3 becomes 1. -2/3 will not become a whole number. So I have x plus 1 and x minus 2/3. So the first parentheses doesn't need to change because there are no fractions. To clear the fraction on the second one, I will multiply x and the -2/3 by 3, and that will leave me with 3x minus 2. On to the last one, 2 times 7 gives me 14. My b value is -9. Numbers that multiply to positive 14 and add to -9 are -7 and -2. I have to divide both of those by my a value, which is 2. -2 over 7 will not reduce to a whole number, but -2 divided by 2 is -1. So I've got x minus 7 over 2 and x minus 1. This time the second parentheses gets to stay the same, but for the first one I'm going to need to multiply by my denominator, and I will get 2x minus 7. All right, that wraps up our trinomials for today. We are now going to move on to sum and difference of cubes. We had a special way to factor differences of squares, and there is also a special way to factor the sum and difference of two cubes. So if you have two perfect cubes added together, whatever the cube root of each term is, it will factor out as such. A plus b times a squared minus ab plus b squared, and that second parentheses got left off. If you have difference of two perfect cubes, whatever the cube root of each term is, that factors out to, and this should be a minus b times a squared plus ab plus b squared, also missing that parentheses. So these are the two formulas we're going to use. You do not have to memorize them, but you will need to be able to memorize some perfect cubes so that you can recognize when you have them. So starting with these four examples here, on A, my two cubes are x to the third and 8. So that means my a value is x, that's the cube root of x to the third. And our b value is going to be 2, which is the cube root of 8. So using my formula, I'm going to have a plus b, which will be x plus 2, times a squared, that will give me x squared, minus a times b, that will be 2x, plus b squared, 2 squared is 4. And again, you could multiply this back out to make sure you got what you started with. Just keep in mind you would have to do multiplication 6 times, not just 4. Moving on to example B, I've got 27y cubed plus 8. So my a term is going to be the cube root of 27y to the third. That will be 3y. And my b term will be the cube root of 8, which again is 2. This is the sum of two cubes, so I will use that formula. That will be a plus b, 3y plus 2, times a squared. When I square 3y, keep in mind I have to square the 3 and the y, so that will be 9y squared, minus a times b, 3y times 2 is 6y, plus b squared, 2 squared is going to be 4. Moving on to C, I've got 216x cubed minus 125y cubed. So this means that our a term will be the cube root of 216x to the third, and that will be 6x. B will be the cube root of 125y to the third. That will be 5y. This is now difference of two cubes, so that formula is going to be a, 6x, minus b, 5y, times a squared. Again, when I'm squaring 6x, that means I have to square both parts, so that will be 36x squared, plus a times b, 6x times 5y is 30xy, plus b squared. Again, if I'm squaring 5y, I have to square both parts. That will be 25y squared. And our last one, 8x to the third minus 64. That means that a is going to be 2x and b is going to be 4. So using my formula, 2x minus 4 times a squared will give me 4x squared, plus a times b will give me 8x, plus b squared will give me 16. All right, our final topic of today is factoring by grouping. This is when you have 4 or more terms. What we're going to do is split them up into groups of 2 and factor out a GCF and see if we can use that GCF to create just a product of 2 terms. So starting with A here, I'm going to split up my first 2 terms and my second 2 terms. With the first 2, I can take out a y squared, and that will leave me with y plus 5. Again, you could distribute that back out to make sure you factored correctly. On the second group, I can take out a 7, and that will leave me with y plus 5. What I see now here is y plus 5 is now a common factor between these 2 terms. So I can bring that into the front, and that will leave me with y squared plus 7. And you could FOIL to make sure you did this correctly. Moving on to B, I'm splitting up and grouping. On the first group, I can factor out an 8x squared, and that will leave me with x plus 7. In the second group, I can factor out a 3, and that will leave me with x plus 7. X plus 7 is now a common factor, and if I bring that to the front, I am left with 8x squared plus 3. On C, grouping. On the first term, I can factor out a 15y squared, and that leaves me with y minus 5. And on my second group, I can factor out a 35, and that will also leave me with y minus 5. Y minus 5 is now a perfect, a common factor, and that will leave me with 15y squared plus 35. And if we wanted to, because between 15y squared and 35, those two also have a common factor of 5, I could bring that into the very front, and that would leave me with 3y squared plus 7 if we were to factor completely. On to D again. In our groups, 48x cubed minus 6y squared, I can factor out a 6x squared, and that will leave me with 8x minus 1. On the second one, I can factor out a negative 48, and that will leave me with an 8x minus 1 as well. So factoring out 8x minus 1, I'm left with 6x squared minus 48. And again, this has a common factor of 6, so I could bring that to the front, and that will leave me with x squared minus 8. Okay, last but not least, some mixed practice. The hint here is take out the GCF first if there is one. So starting on A, all of these numbers, negative 5, negative 65, and 150, have a factor of negative 5 that I can take out, and that will leave me with x squared plus 13x minus 30. So this is now a trinomial I can do my x method with. Negative 30 and 13, well, those two values would be negative 10, or sorry, positive 15 and negative 2. And then a was 1, so I don't need to worry about dividing. So that negative 5 stays in the front, and now I have x plus 15 and x minus 2. Moving on to b, 18x to the 10 and negative 2. Those have a common factor of 2, so I can start there, and I have 9x to the 10 minus 1. Well, that is now a difference of 2 squares. Remember, we learned that last time. That factors to a minus b times a plus b. Here, a would be 3x to the 5th, and b is 1. So that 2 needs to stay in the front, and then I have 3x to the 5th minus 1 times 3x to the 5th plus 1. On c, I can take out a common factor of 4, and that will leave me with x cubed minus 125. This is now a difference of 2 cubes, where a is x and b is 5. So that 4 stays in the front, and then using my difference of cubes formula, I have x minus 5 times x squared plus 5x plus 25. And then on the last one, I can take out a common factor of 2. That leaves me with x cubed plus 8. This is a sum of 2 cubes, so my a term is y, my b term is 2. So that 2 stays in the front, and now I can just use my sum of 2 cubes formula, y plus 2, y squared minus 2y plus 4. That wraps up our day 2 notes on factoring.